What if the universe isn't just vast but far stranger than we could ever imagine? Picture this. The stars above your head might be mere reflections in a cosmic mirror, or perhaps there are infinite versions of you scattered across countless parallel universes. From the possibility that our reality exists within a meticulously crafted simulation to the idea that the night sky holds the secrets of alien megastructures, space is filled with mysteries that defy everything we think we know. In this video, we are going to unravel 50 of the most bizarre and mind-bending theories about the cosmos, ideas so extraordinary they could forever change the way you see the universe and your place within it. Get ready to venture into the unknown where science meets speculation and nothing is quite as it seems. Stay with us because by the end, you might just question the very fabric of reality itself. Now turning to the first mind-bending concept, let's explore the theory of the expanding universe. Imagine for a moment that the cosmos is not a stationary entity but a dynamic, ever-growing expanse. This groundbreaking idea was first uncovered by the brilliant astronomer Edwin Hubble in the early 20th century. By observing distant galaxies, Hubble made a startling discovery. The farther away a galaxy is, the faster it seems to be moving away from us. This revelation shattered the long-held belief in a static universe and hinted at something extraordinary. The universe itself is expanding, but that's not all. Later observations revealed an even more puzzling twist. This expansion is not slowing down, as one might expect due to gravity, but rather accelerating. Scientists attribute this mysterious force driving the acceleration to something they call dark energy, an enigmatic phenomenon that remains one of the greatest puzzles in modern cosmology. If the universe continues to expand at this accelerating rate, it raises profound questions about the fate of the cosmos. Will everything stretch so far apart that galaxies, stars, and even atoms themselves disintegrate in a so-called Big Rip? Or could the universe eventually slow down and collapse back into itself in a dramatic reversal known as the Big Crunch? This ever-expanding universe forces us to confront the astonishing scale and behavior of the cosmos, shaking the very foundation of how we understand reality. And it's only the beginning. Moving forward, we'll dive deeper into theories that stretch the limits of imagination and science alike. As the next challenge unfolds, let's dive into the mind-bending idea of the multiverse. Imagine for a moment that the universe we know is just one of countless others, each existing simultaneously but separated by dimensions we cannot yet perceive. This is the concept of the multiverse, a collection of infinite parallel universes where every possible variation of existence plays out. It might sound like pure science fiction, but some of the most advanced fields in physics, such as quantum mechanics and string theory, lend surprising credibility to this astonishing idea. For instance, in quantum mechanics, the principle of superposition suggests that particles can exist in multiple states at once until observed. Expanding this notion, some theories propose that every decision, every chance event, could create a branching universe where alternate outcomes unfold. In one such universe, your life might look slightly different. Perhaps you chose a different career, live in another city, or have made choices that led to an entirely separate path. On a grander cosmic scale, string theory suggests that our universe may be just one bubble in a vast cosmic foam, with countless other bubbles floating around, each governed by its own unique set of physical laws and constants. These theories not only stretch the boundaries of human imagination, but also challenge our deepest notions of reality. If these parallel universes exist, could we ever find a way to detect them, or perhaps even interact with them? The multiverse theory, while still unproven, invites us to rethink the very nature of existence, leaving us to wonder just how vast and unpredictable reality might truly be. And this is just the beginning. Moving forward, we'll navigate even more theories that force us to question the very fabric of what we consider possible. As the next challenge unfolds, let us step into the intriguing world of the simulation hypothesis, a theory that suggests our entire reality could be nothing more than a highly advanced computer simulation. This concept, while seemingly drawn from the pages of a science fiction novel, has been seriously considered by philosophers and scientists alike. One of its most prominent proponents, philosopher Nick Bostrom, posits that if civilizations can eventually reach a level of technological advancement capable of creating highly detailed simulations of conscious beings, then the chances are extraordinarily high that we ourselves are living in one of those simulations. Think about it for a moment. How would a simulated reality appear any different from what we experience now if every sensation, every particle, and every law of physics were perfectly programmed? It is an idea that has even found its way into popular culture, with iconic films like The Matrix painting a vivid picture of what this scenario might look like. Philosophically, this hypothesis forces us to confront profound questions about the nature of existence and free will. Would our actions matter in a simulated world? Could this mean the concept of reality itself is subjective, defined not by what is real but by what we perceive? On the scientific side, some have suggested that certain anomalies in the universe, like the discrete nature of space-time, could be clues pointing towards a pixelated, programmed reality rather than a continuous one. Yet, skeptics argue that such a hypothesis, while intellectually fascinating, is currently unfalsifiable, making it impossible to prove or disprove with the tools we have today. Still, the mere contemplation of this idea challenges us to think beyond the conventional boundaries of reality, leaving us to wonder whether the very fabric of existence might be a construct designed by an intelligence we cannot yet comprehend. As we peel back the layers of these mind-bending possibilities, the next theory will propel us even further into the profound mysteries of the cosmos. Now turning to the enigmatic concept of dark matter, let us explore the theory surrounding this unseen force that comprises the majority of the universe's mass. Unlike the familiar matter that makes up stars, planets, and even our own bodies, dark matter neither emits nor absorbs light, making it completely invisible to the human eye and even to the most sophisticated telescopes. Yet its presence is almost undeniable. Scientists first theorized its existence when observing galaxies behaving in ways that defied the laws of physics as we understand them. For instance, stars near the edges of galaxies are moving at speeds that suggest there must be a tremendous amount of additional mass providing gravitational pull, mass that we simply cannot see. This hidden mass is what we call dark matter. Intriguingly, it is thought to make up around 85% of all matter in the universe, yet its true nature remains one of the greatest mysteries of modern science. To unravel this cosmic puzzle, researchers have turned to a range of experiments, such as building underground detectors designed to capture rare interactions between dark matter particles and ordinary matter. Others look to the skies, analyzing massive gravitational effects like the bending of light from distant galaxies, a phenomenon known as gravitational lensing, which also points to the presence of this invisible substance. Despite these efforts, dark matter continues to elude direct detection, leaving us with more questions than answers. Could it consist of exotic particles yet to be discovered? Or perhaps it operates through forces and dimensions that challenge our current understanding of physics. Dark matter not only reshapes how we view the cosmos, but also highlights how much we have yet to learn about the fundamental nature of our universe. As we ponder these unanswered questions, the next theory delves into an equally perplexing force that drives the expansion of space itself. Now turning to the mysterious concept of dark energy, we venture into one of the most perplexing ideas in cosmology. While dark matter captivates us with its invisible mass, dark energy takes this enigma a step further, as it is believed to be the force driving the accelerated expansion of the universe. Imagine this: instead of galaxies slowing down or pulling closer together due to gravity, they are moving away from each other at increasingly faster rates. This strange phenomenon was first observed in the late 1990s when scientists studied distant exploding stars called supernovae. These cosmic explosions served as markers for measuring distances and motions in the universe. To their astonishment, the data revealed that the expansion of the universe was not decelerating as previously assumed, but was speeding up. This groundbreaking discovery earned the researchers a Nobel Prize in 2011 and introduced the world to the concept of dark energy. But what is dark energy? At its core, it represents the unknown. It is thought to make up a staggering 70% of the universe, yet its nature remains elusive. Some theories propose it could be a property of space itself, with every tiny volume of empty space generating a small amount of energy that pushes the cosmos outward. Others speculate that it might stem from an entirely new fundamental force or field, one that defies all known laws of physics. The effects of dark energy are not just theoretical. They are visible in the patterns of the cosmic microwave background radiation and the large-scale structure of the universe. Yet, its essence continues to evade direct observation. Dark energy challenges not just our understanding of gravity, but the very fabric of reality. If it continues to dominate over time, it could mean a future where the universe becomes cold, empty, and isolated as galaxies drift so far apart they can no longer interact. Or perhaps it holds secrets that could one day unlock new dimensions of physics altogether. As we stand at the edge of this vast unknown, we are reminded of how little we truly grasp about the forces shaping existence itself. And this brings us to another speculative idea that turns our understanding of black holes upside down, the theory of white holes. As the next challenge unfolds, we delve into the intriguing concept of white holes, a theoretical counterpart to the ever-enigmatic black holes. While black holes are known for their immense gravitational pull that swallows everything in their vicinity, including light, white holes turn this idea on its head. Imagine a cosmic object that instead of pulling matter and energy inward, expels them outward in a powerful burst, allowing nothing to enter its boundaries. In essence, a white hole is the polar opposite of a black hole, and its existence, though purely hypothetical, pushes the boundaries of our current understanding of physics. The concept of white holes arises naturally from the equations of general relativity, the same framework that predicted black holes long before they were observed. Some scientists speculate that white holes might be connected to black holes, potentially forming what is known as a wormhole, a tunnel-like structure that could link two distant points in space and time. This connection evokes tantalizing possibilities of faster-than-light travel or even shortcuts to other parts of the universe. However, current physics suggests that such structures would be incredibly unstable, collapsing almost as soon as they form. Observationally, no definitive evidence for white holes has been found. Yet, their speculative nature has driven theorists to ponder whether mysterious cosmic phenomena, like certain bursts of gamma rays or unexplained high-energy signals, could be linked to them. Some even propose that white holes might emerge at the end of a black hole's life cycle, releasing all the matter and energy that the black hole once consumed. If true, this could revolutionize our understanding of entropy and the life cycle of cosmic structures. White holes remain one of the most imaginative ideas in astrophysics, challenging not only how we perceive black holes but also the very nature of spacetime itself. Their existence, if proven, could unlock profound new insights into the interconnectedness of the universe. And speaking of spacetime, it brings us to another mind-bending idea that confronts our perception of reality: the possibility of using time travel loopholes. With the next phase of the journey in sight, we turn to one of the most captivating and controversial concepts in theoretical physics: time travel loopholes. At the heart of this idea lies the intricate and mysterious fabric of spacetime, a four-dimensional continuum that combines the three dimensions of space with the dimension of time. Theoretically, space-time is not rigid but can bend, twist, and fold, creating the potential for shortcuts through the cosmos, known as wormholes. Wormholes, sometimes referred to as Einstein-Rosen bridges, are speculative tunnels that could connect distant points in both space and time, potentially enabling travel not only across vast cosmic distances but also into the past or the future. The allure of time travel is irresistible, but it's steeped in paradoxes and challenges that question the very foundations of logic and causality. One of the most famous of these is the grandfather paradox. Imagine you could travel back in time and inadvertently or intentionally alter events, such as preventing your grandfather from meeting your grandmother. If their union never occurred, you would never exist, which raises the mind-bending question. If you never existed, how could you have traveled back to disrupt their meeting in the first place? This creates a loop of contradictions that physicists and philosophers alike have struggled to reconcile. Another intriguing proposal is the concept of closed time-like curves, theoretical paths through spacetime that loop back on themselves. These could, in principle, allow an object or individual to travel to a past moment in time and then return to the present. However, such curves are purely hypothetical and face significant scrutiny from the laws of physics as we understand them today. Most experts agree that the extreme gravitational forces and instability involved in creating these spacetime warps would make them impossible to sustain. Despite the challenges, modern research continues to explore the feasibility of time travel. Some scientists suggest that even if backward time travel proves unattainable, forward time travel could be achievable. For instance, Einstein's theory of relativity indicates that time slows down for objects moving at speeds close to the speed of light. This means that astronauts traveling on a near-light-speed spacecraft could return to Earth to find that time has passed much more quickly for those who stayed behind, effectively traveling into the future. Time travel also has implications that extend far beyond science fiction. It forces us to reconsider the nature of time itself. Is time a linear progression, or is it, as some theories suggest, more like an unchanging landscape where all moments coexist? If the latter is true, then traveling to another point in time might not involve altering reality, but simply shifting one's perspective within a fixed timeline. While no concrete evidence for time travel has yet emerged, the quest to understand its possibilities pushes the boundaries of human imagination and scientific exploration. Whether it remains an unattainable dream or one day becomes a reality, the search for time travel loopholes taps into a universal desire to rewrite, revisit, or reshape the past and the future. And speaking of the future, the next theory challenges even our most fundamental understanding of what the universe might truly be, diving into the astonishing idea of the cosmic hologram. Now turning to the next theory, we dive into the mind-bending notion of the cosmic hologram, a concept that challenges the very fabric of our understanding of reality. Imagine for a moment that everything you see, touch, and experience, the vast galaxies, the unending blackness of space, and even the very Earth beneath your feet, is not what it seems. Instead, some scientists propose that the entire universe might be a holographic projection, where the three-dimensional reality we perceive is actually encoded on a two-dimensional surface. This idea stems from studies in black hole physics, particularly the puzzling relationship between a black hole's surface area and the information it contains. The holographic principle, as it is known, suggests that all the information about the three-dimensional contents of a region of space can be encoded on a two-dimensional boundary of that space. This concept gained traction when physicist Leonard Susskind and Nobel laureate Gerard T. Hooft explored how black holes, rather than swallowing information entirely, might store it on their event horizons, the surfaces beyond which nothing can escape. It's as though the universe operates like a cosmic data storage device, with the information about every particle and interaction preserved on a distant surface. This notion is further supported by the strange and non-intuitive behavior of quantum particles, which often defy classical logic. For example, quantum entanglement, where particles separated by vast distances appear to instantaneously influence each other, hints at underlying connections that might align with this holographic framework. Recent studies, such as those at the European Organization for Nuclear Research and other advanced physics laboratories, have begun to test some of the mathematical implications of this principle. Researchers are examining whether spacetime itself might emerge from quantum entanglement patterns, akin to a giant projection. If proven true, this would revolutionize our understanding of existence, suggesting that the cosmos we inhabit has more in common with a grand illusion than the tangible reality we've always assumed. Such a perspective might seem abstract, but it raises profound philosophical questions. What if our sense of depth and materiality is just an elaborate construct, with the true nature of the universe hidden in the intricate patterns of quantum information? While experiments and observations continue to probe the limits of this hypothesis, one thing is certain: the idea of the cosmic hologram pushes us to reconsider the fundamental nature of reality itself. As the mystery deepens, we journey further into the unknown, where the next theory brings us face to face with a question that has haunted humanity for generations. Why have we not encountered alien life, despite the high probability of its existence? Prepare to delve into the enigma of the Great Filter. As the next challenge unfolds, we encounter the perplexing enigma of the Great Filter, a theory that seeks to unravel one of the most haunting questions posed by the Fermi paradox. If the universe is so vast and teeming with countless stars and planets capable of harboring life, why have we not yet encountered any signs of extraterrestrial civilizations? The Great Filter suggests that somewhere along the evolutionary path from simple molecules to advanced spacefaring societies, there exists a nearly insurmountable barrier that prevents most forms of life from reaching a stage where they can explore the cosmos or communicate with others. But where exactly this filter lies remains an open and profound mystery. Could the Great Filter be lurking in our distant past? Some scientists speculate that the transition from non-living chemicals to the first self-replicating organisms, a process known as abiogenesis, might be so extraordinarily rare that it has occurred only once in the entire universe. If that is the case, then humanity may already have surpassed the filter, making us a cosmic anomaly. On the other hand, others argue that the filter could be far ahead of us, waiting in the future. This leads to chilling possibilities. Perhaps the development of advanced technology inevitably triggers self-destruction through catastrophic events like nuclear warfare, environmental collapse, or uncontrollable artificial intelligence. If true, then humanity may still face this looming challenge, and our survival will depend on whether we can navigate it successfully. Alternatively, the Great Filter might not be a single event but a series of hurdles, each progressively more difficult to overcome. These could range from the emergence of complex multicellular organisms to the leap from intelligent thought to sustained technological advancement. It is also possible that advanced civilizations do exist but are deliberately concealing themselves or are so far removed in space and time that communication is practically impossible. The implications of the Great Filter are both inspiring and unsettling. If the filter lies in our past, then we may be among the rarest forms of life ever to exist, a profoundly humbling realization. However, if it lies ahead, humanity's future hangs in the balance, urging us to act with caution and foresight as we push the boundaries of science, technology, and social progress. Whichever the case, the Great Filter compels us to confront the fragility and preciousness of our existence among the stars. And with that, we turn our gaze to the next mind-boggling idea that challenges our concepts of alien intelligence. Could some of the strange phenomena we observe in space actually be colossal alien megastructures? Let's unravel this intriguing possibility. Now turning to the concept of alien megastructures, we find ourselves captivated by the mystery surrounding a star officially known as KIC 8,462,852, but more famously referred to as Tabby's star. This celestial oddity first drew attention when astronomers noticed something extraordinary. Its light was dimming in ways that defied all conventional explanations. Unlike the predictable patterns caused by orbiting planets or other natural phenomena, Tabby's star exhibited irregular and significant drops in brightness, leading some scientists to propose an astonishing possibility. What if these fluctuations were caused by an advanced extraterrestrial civilization constructing a colossal megastructure around the star? The idea stems from a theoretical concept known as a Dyson sphere, a hypothetical structure that an advanced civilization might build to harness energy directly from a star. If such a structure were being constructed around Tabby's star, it might explain the irregular and dramatic dimming observed from Earth. While there is no direct evidence to support this theory, its mere consideration highlights the boundless ingenuity of human curiosity. Scientists have also explored alternative explanations like swarms of comets, obscuring dust clouds, or even peculiar processes within the star itself. Yet, none of these theories have been able to fully account for the bizarre behavior of Tabby's star, keeping the idea of an alien megastructure tantalizingly alive. But Tabby's star is not the only source of speculation when it comes to potential alien megastructures. In another breathtaking example, astronomers studying fast radio bursts, enigmatic, extremely short-lived bursts of radio waves from distant galaxies, have suggested that they might be artificial in origin. Could these bursts be signals from advanced civilizations, or perhaps the byproduct of massive alien engineering projects? The truth remains elusive, but the mere possibility invites us to expand our imagination about what might be lurking in the depths of the cosmos. Such theories, though speculative, serve as a reminder of how little we truly know about the universe. Tabby's star and similar phenomena challenge us to confront not only the limits of our understanding, but also our assumptions about what intelligent life might look like and how it might interact with its environment. They urge us to keep searching, to keep asking questions, and to remain open to the incredible. As these mysteries deepen, one thing becomes clear. When it comes to the cosmos, certainty is an illusion, and wonder is our greatest guide. Moving forward, we dive into yet another cosmic riddle, one that reimagines the very fabric of existence itself. Let us explore the mind-bending hypothesis that space, as we know it, might actually be a living, conscious entity. With the next phase of the journey in sight, we peer into a theory that stretches the boundaries of imagination, the idea that space itself could be a living, conscious entity. This thought-provoking concept has its roots in both ancient philosophy and modern scientific speculation, offering a lens through which to reimagine the cosmos as more than just an empty expanse. Ancient civilizations often personified the heavens, attributing divine qualities to the stars and planets. These early interpretations reflected a sense of interconnectedness with the universe that resonates with this contemporary hypothesis. In modern times, this idea has gained speculative traction, particularly in fields like panpsychism, which suggests that consciousness might be a fundamental feature of the universe, present even in the seemingly lifeless void of space. Could space itself, with its intricate interplay of galaxies, dark matter, and energy, possess some form of awareness? Proponents of this theory argue that the universe's extraordinary level of order, from the precise laws of physics to the enigmatic forces governing its expansion, might hint at an underlying consciousness, a kind of cosmic mind permeating all of existence. Adding to this speculation, some researchers have explored whether the intricate web of cosmic filaments, the massive structures connecting galaxies across vast distances, could mirror neural networks found in living organisms, drawing eerie parallels between the universe's design and the structure of a brain. While such comparisons are largely metaphorical, they ignite the question: If the cosmos operates like a living system, could it also be self-aware? Though evidence for a conscious universe remains elusive, the sheer possibility invites deep reflection. What if the very fabric of space-time, which serves as the stage for all existence, is not passive but dynamic, not indifferent but alive in ways we cannot yet comprehend? The implications would challenge how we perceive our place in the cosmos, suggesting that humanity is not merely an observer of the universe but a participant in a conscious, living entity that extends far beyond our understanding. As we marvel at the profound mystery of a possibly living cosmos, one cannot help but wonder what other hidden layers of reality await discovery. Moving forward, we explore an astounding astrophysical phenomenon that has left scientists both puzzled and intrigued: the enormous gamma-ray emitting structures known as the Fermi bubbles. Now turning to the next enigma of the cosmos, we dive into the mystery of the Fermi bubbles. These colossal gamma-ray emitting structures tower above and below the center of our Milky Way galaxy, stretching for tens of thousands of light years. Discovered in 2010 by scientists analyzing data from the Fermi Gamma-Ray Space Telescope, these bubbles have baffled astronomers ever since. What could have caused such immense and powerful formations to emerge? Theories abound, ranging from violent black hole activity to remnants of ancient galactic eruptions. Some researchers propose that these bubbles are the result of past outbursts from the supermassive black hole at the heart of our galaxy, known as Sagittarius A. Such bursts could have unleashed enormous energy, carving out these vast, glowing cavities in the surrounding space. Others suggest that the bubbles may have been created by stellar explosions or intense star formation in the galaxy's core, events that would have hurled streams of gas and particles outward at incredible speeds. Adding to the intrigue, the Fermi bubbles emit gamma rays, an extremely high-energy form of radiation, which raises questions about the processes fueling these emissions. Could they be linked to dark matter interactions, providing clues to one of the greatest mysteries in modern astrophysics? Or are they simply the remnants of more familiar phenomena, scaled up to cosmic proportions? Despite years of study, the true origin of the Fermi bubbles remains shrouded in uncertainty, leaving us to ponder the dynamic and sometimes chaotic forces shaping the universe's landscape. With so much still unknown, these structures remind us of how much more there is to discover about the Milky Way and the forces at work within it. From the mysterious glow of the Fermi bubbles, our journey takes us next to a truly unsettling concept: the possibility that the very fabric of our universe might one day collapse in a catastrophic event known as vacuum decay. As the next challenge unfolds, we come face to face with a theory that is as terrifying as it is mind-boggling: the concept of vacuum decay. Imagine for a moment that the universe we inhabit is not in its most stable state. Instead, it could exist in what physicists call a metastable vacuum, a kind of precarious energy state that only appears stable but may not truly be the lowest, most secure state possible. The frightening implication here is that our entire cosmos could suddenly, and without warning, transition to a lower energy state, causing a chain reaction that ripples across the universe at the speed of light. This is the essence of vacuum decay, a phenomenon that could effectively rewrite the rules of physics and bring reality as we know it to an abrupt and catastrophic end. The root of this idea lies in quantum field theory, which describes how the fundamental forces and particles of our universe interact. According to this framework, our universe's vacuum, essentially the space that appears empty, is not entirely devoid of energy. Instead, it is filled with quantum fields, and these fields could potentially exist in different configurations, each with its own energy level. In the vacuum decay scenario, if our universe is not in the most stable and lowest energy configuration, but rather in a metastable one, even the smallest disturbance, like quantum fluctuations, could trigger a collapse to a more stable vacuum state. This collapse would release an enormous amount of energy, creating a bubble of true vacuum that rapidly expands, annihilating everything in its path. Stars, planets, galaxies, even the fundamental forces like gravity and electromagnetism could cease to exist as we know them, replaced by new and completely alien rules of physics inside this true vacuum. What makes this theory even more unsettling is its unpredictability. There would be no advance warning, no cosmic sign of impending doom. If vacuum decay were to occur, it would simply happen, silently and inexorably consuming the universe. While this idea might sound like pure science fiction, it is grounded in real physics and has been explored in academic studies by scientists such as Nobel laureate Steven Weinberg. Some theorists argue that the chances of vacuum decay happening are incredibly slim, given the vastness of time and the stability of the universe we observe today. Others suggest that certain cosmic events, such as high-energy particle collisions, could theoretically accelerate the process, though this remains highly speculative. Still, the possibility of vacuum decay reminds us of just how fragile and uncertain our understanding of existence can be. It forces us to confront the idea that our universe, while awe-inspiring and seemingly eternal, might be governed by forces and phenomena far beyond our current comprehension. Moving forward, let us turn our gaze from this unsettling prospect to another strange and thought-provoking idea: the possibility of a shadow biosphere hidden right here on Earth. Now turning to the intriguing possibility of a shadow biosphere, we are faced with a hypothesis that fundamentally challenges how we define life itself. What if alien life is not out there, light years away among the stars, but right here on Earth, hidden in plain sight? The concept of a shadow biosphere suggests that there could be entire ecosystems of life forms on our planet that we have never detected because they do not share the same biochemistry as life as we know it. Unlike all known life on Earth, which is based on carbon, water, and DNA, these hypothetical organisms could operate on entirely different biochemical pathways, using substances like silicon, ammonia, or even arsenic as their foundation. This idea stems from our limited perspective on what constitutes life. Our scientific tools and methods are designed to detect and study organisms that fit within the framework of the biochemistry we are familiar with. But what if this framework is too narrow? The shadow biosphere theorizes that alternative forms of life might exist in extreme environments, places with high temperatures, intense radiation, or unusual chemical compositions where we typically do not expect to find conventional life. Imagine microbes thriving in the boiling acid pools of Yellowstone National Park, or organisms existing deep within Earth's crust, using methane or sulfur instead of oxygen. Such possibilities are not entirely far-fetched. For instance, scientists have discovered extremophiles organisms that live in extreme conditions once thought uninhabitable. These discoveries have expanded our understanding of where life can exist, but they still operate within the boundaries of familiar life chemistry. A shadow biosphere would go a step further, completely rewriting the rules by showcasing life that functions under principles entirely alien to us. This hypothesis isn't just speculation for its own sake. Searching for a shadow biosphere could have profound implications. If we were to find such alternative life forms, it would suggest that the origins of life on Earth may have occurred more than once in parallel but separate processes. This would dramatically increase the likelihood that life exists elsewhere in the universe, as it would mean that life is an inevitable consequence of the right conditions, rather than an incredibly rare phenomenon. Efforts to uncover evidence of a shadow biosphere are ongoing, with researchers exploring environments that might harbor such life. For example, studies are being conducted on microorganisms that seem to defy the rules of conventional biology, like those found in Mono Lake, California, which survive in arsenic-rich waters. While no definitive proof has been found yet, the search continues, fueled by the tantalizing possibility that alien life is not a distant concept but a hidden reality right under our noses. As we ponder this revolutionary idea, let us prepare to venture further into the unknown with a theory that pushes the origins of life beyond Earth itself, the concept of panspermia. Now turning to the concept of panspermia, we delve into a theory that quite literally takes the origins of life on Earth out of this world. Panspermia suggests that life as we know it may not have started here on Earth, but instead originated elsewhere in the cosmos, carried across the vastness of space by natural cosmic vehicles like meteoroids, comets, or even dust particles. Imagine microscopic life forms hitching a ride on these celestial bodies, enduring the harsh vacuum of space, and eventually crash-landing on a young, hospitable Earth billions of years ago. This idea challenges the traditional view that life began from scratch on Earth through a gradual process of chemical evolution. Instead, panspermia opens the possibility that life, or at least the essential building blocks for life, might be an interstellar traveler, hopping between planets, moons, or even star systems. Take, for example, the Martian meteorites discovered on Earth. Some of these rocks are known to have originated on Mars and were ejected into space by asteroid impacts before eventually making their way to our planet. Could they have carried microbial life hidden within their microscopic pores, shielded from radiation during their journey? The idea does not end there. Some proponents of panspermia even suggest that life could be an inevitable byproduct of the universe's processes, spreading like cosmic seeds across galaxies. This leads to the tantalizing speculation that planets like Mars or the icy moons of Jupiter and Saturn might share a common ancestry with Earth. In essence, life on Earth may be one chapter in a much grander cosmic story. Scientists have found intriguing clues supporting panspermia. For instance, extremophiles, those hardy organisms capable of surviving extreme conditions, have been shown to endure the vacuum of space, intense radiation, and extreme temperatures. This resilience suggests that microbes might survive long space journeys, making interplanetary travel plausible. Furthermore, organic compounds, the building blocks of life, have been found on comets and asteroids, providing a potential source for sowing life on suitable planets through impact. While panspermia does not answer the ultimate question of how life first originated, it merely shifts the starting point to another location. It profoundly expands our understanding of life's potential distribution in the universe. If panspermia is true, then life may be far more common than we currently imagine, scattered like stardust throughout the cosmos. As we continue searching for life beyond Earth, the concept of panspermia inspires us to look not just at environments where life might exist today, but also at the celestial journeys life might have taken to reach those places. With this thought in mind, let us press forward to explore an age-old cosmic enigma. The question of why, in a universe that seems so vast and full of potential, the night sky remains so dark, with the puzzling paradox of Olbers' paradox. As the next challenge unfolds, we turn our gaze to Olbers' paradox, a puzzle that questions the very nature of our night sky. If the universe truly contains an infinite number of stars scattered across endless space, then why is the night sky dark instead of glowing brightly with starlight in every direction? At first glance, this seems counterintuitive. An infinite universe packed with stars should mean that no matter where we look, our line of sight would eventually land on the surface of a star, creating a brilliant, all-encompassing glow. Yet, when we step outside at night, the vast darkness of the cosmos surrounds us. This paradox has baffled thinkers for centuries, with roots tracing back to discussions in the 18th century. One explanation lies in the concept of the observable universe. While the universe may be infinite, the portion we can see is not. Light from distant stars takes time to reach us, and because the universe has a finite age, around 13 billion years, there hasn't been enough time for the light from all stars to arrive. In this sense, the darkness we see is like looking at a cosmic clock, marking the limits of how far back in time we can observe. Another possible answer involves the expanding nature of the universe itself. As space stretches, the wavelength of light from distant stars is stretched as well, shifting it beyond the visible spectrum into the infrared or even radio wavelengths. This phenomenon, known as redshift, dims the light of faraway stars, making their contribution to the night sky negligible to our eyes. Moreover, modern astronomy reveals that stars are not evenly distributed. They cluster into galaxies separated by vast voids of space. These galactic clusters themselves are finite in number within the observable universe, further reducing the likelihood of an eternally bright night sky. On top of that, cosmic dust and gas scattered between stars can absorb and scatter light, adding another layer of complexity to the paradox. But perhaps the most profound implication of Olbers' paradox lies in how it hints at the dynamic and ever-changing nature of the cosmos. It serves as a reminder that our universe is not static but a living, evolving entity shaped by time, expansion, and the interplay of light and matter. It invites us to look beyond the surface of what we see and consider the deeper truths hiding in the shadows. As we unravel one mystery, another often emerges, drawing us further into the unknown. With Olbers' paradox setting the stage, let us now venture into the realm of speculations that lie on the edge of science. The eerie possibility that our universe itself could be resting on a knife's edge of instability, leading us into the chilling concept of vacuum decay. With the next phase of the journey in sight, let us explore the haunting concept of vacuum decay, a theory that suggests our universe might not be as stable as it appears. Imagine existence as a vast field of energy, a delicate balance we call the vacuum state. Now, what if this state isn't truly stable but instead teeters on the edge of a more stable, lower energy configuration? This is the unsettling idea behind vacuum decay, a sudden and catastrophic event that could disrupt reality itself. At the heart of this theory is the notion of a false vacuum, a state that appears stable but is actually just temporarily holding the structure of our universe together. In this scenario, a small quantum fluctuation or even the natural progression of the vacuum could trigger a collapse, causing a runaway chain reaction. This ripple would propagate at the speed of light, tearing through everything, reshaping the very fabric of existence, and reorganizing fundamental laws of physics into something entirely alien. The terrifying part, there would be no warning. If a vacuum decay event were to occur, it would begin at some distant point in the universe and expand outward like an unstoppable wave. As it spread, it would rewrite reality, rendering everything in its path unrecognizable. The particles and forces that define our world would cease to exist in their current forms, replaced by a new, stable vacuum utterly incompatible with life as we know it. While this might sound like the plot of some apocalyptic sci-fi movie, it is a hypothesis rooted in quantum field theory, which governs the interactions of energy and particles at the most fundamental levels. The Higgs field, a critical component of this framework, plays a key role in this theory. Some calculations suggest that the Higgs field's current energy level might indicate that our universe exists precariously within a false vacuum, though the timeline for potential decay could span billions or even trillions of years, or perhaps never occur at all. Despite the chilling implications, there is no need for immediate panic. Scientists emphasize that the likelihood of such an event happening in our observable universe during our lifetimes is astronomically low. What vacuum decay truly offers is a sobering reminder of how fragile and fleeting our reality might be, and an invitation to appreciate the intricacies of the cosmic mechanisms that allow us to ponder these mysteries at all. As we leave the shadow of this cosmic instability, we now glance back towards Earth itself, where hidden forms of life may already exist in ways we cannot yet perceive. This brings us to the eerie hypothesis of the shadow biosphere.